Hi all, hello and welcome everyone to ManageEngine NetFlow Analyzers webinar titled Network Performance Monitoring at Minimal Capex. Today's webinar will discuss about some of the technologies Cisco has on their devices to assist with network performance monitoring, how they can help you create a high-performance network without having to purchase any additional hardware or multiple software. So, during today's sessions, your phone line will remain muted. You can type in your questions using the option available in your GoToWebinar window, and our expert panel will respond. We also have a question and answer session at the end of the webinar. So once again, welcome to the webinar on network performance monitoring at minimal capex. So before we start, a very brief introduction on ManageEngine. ManageEngine offers simple, easy-to-use IT management products at a price that every business type can afford. ManageEngine products can technically cater to both the SMBs as well as the large businesses. We have products for anything ranging from network and application management to desktop management, Active Directory, wireless log analysis, vulnerability assessment, password management, almost anything that an organization needs for its IT management. So this is what today's webinar will discuss. We'll talk very briefly on the need for network performance monitoring, some of the requirements or wish list of a network admin, and then the technologies Cisco has to help with the network performance monitoring. And then during that, we'll also see very briefly on what Cisco's flexible NetFlow is, and then we'll move on to NetFlow Analyzer, or what ManageEngine NetFlow Analyzer can do, leveraging on the Cisco technologies to help you with your monitoring. So what is the need for network performance monitoring? Today, it's like almost every enterprise depends a great deal on WAN connectivity, like be it for business transactions, data storage, connectivity within your branches. There's a huge amount of dependency on WAN connectivity. Like I would say at least 75% of the enterprises would end up losing a good amount of money if the WAN connectivity is down. So ensuring that a fair amount of bandwidth is always available is one of the most widely used methods to ensure network performance. So at a time when there was only packet analysis for network monitoring, the most common solution for connectivity issues was, any connectivity issue which could not be pointed at anything else other than the network was to throw in more bandwidth. So today the bandwidth costs have decreased to a very large extent, and you can see that almost everywhere across the world bandwidth costs have been decreasing. So with what happens with reduced bandwidth costs is people are again still, some of the enterprises have been resorting to throwing in more bandwidth when when there is a performance issue in the network, when some applications are reported as not functioning, or maybe when there is a business application delivery failure. So even though the bandwidth cost is decreasing, the other factor, the other side of the coin is that the number of applications and services being used in the network also has increased exponentially. Like users now have 10G LAN networks or very high-speed WAN connections. So these links, even though they are high-speed links, even though the speed has increased over the last couple of years, even then these high-speed links, you will still find them 70% utilization, at 70% utilization. Because with the coming down of bandwidth cost, the traffic, the amount of traffic or the volume of traffic used also has increased. So more bandwidth is not the solution to network performance issues. So another commonly used method for performance issues is adding some WAN optimization. So you can add some WAN optimization device or purchase a high-end bandwidth connection, high-speed bandwidth connection. So both of them are not the solution. Actually, what you can do, with performance monitoring, you can actually save a lot of money, a lot of capex before you input your capex into that extra bandwidth you were planning to do, or put the capex into the WAN optimization devices you had planned to purchase. You could actually do some performance monitoring, analyze your traffic behavior, find out what is happening in your network. Maybe there is a high volume of peer-to-peer application usage, or maybe business critical applications, they do not have the required priority. Maybe that's why they're not getting delivered across the WAN. So another factor is maybe those are planning to add some bandwidth for the sake of this new application, new business app. So you will actually need to know how this application will perform when deployed on the current link. So these are some of the things actually network monitoring, active network monitoring can do. Help you find out if your bandwidth is being properly utilized, if the current link is capable of carrying the additional traffic you planned. And another factor is the VoIP. VoIP is being deployed almost everywhere today. So you would like to know whether or how VoIP will perform when you are deploying it on your current link, because with VoIP, quality of the call, the performance of the call really matters. And then again, there is this factor where whether maybe there is whether your network could be under attack, or maybe there are some DOS attacks or malware spreading across your network. So if you keep a track on all this, keeping a track on all this will help you troubleshoot issues actually as soon as they occur. So it's only with an active monitoring system in place that you can drill down to the root cause of the network connectivity and find out whether the connectivity issue was a QoS failure or a traffic spike or a DOS attack. So these things actually help you save your money, get better performance from your network, and which again is business uptime, and finally that again leads to more money saved. So for today's bigger or faster or much more complex networks, you definitely will need network performance monitoring. And over the next few slides, we'll see what I've seen to be like. We have been interacting with a lot of network administrators from the ManageEngine users, and I'll discuss some of the factors which I've seen to be the wish list of most of today's network administrators. So stuff like finding out the cause of the traffic spike, do traffic analytics, capacity planning decisions, finding the peer-to-peer application usage, viewing the performance of your QoS policies, measuring the data and voice performance, ensuring the network is secure. So these are some of the many things actually a network administrator will wish. So first thing, let's talk about bandwidth monitoring. Bandwidth monitoring and traffic analytics is a very important factor in performance monitoring. I mean, it would be an understatement if I just stated as important. It's like high up and there in the list of must-do things for your network. So you will need to analyze the link usage, find traffic patterns, and if you can get that report in real time, all the more better. So it's really important to know how much of your T1 line is being used. So that is what bandwidth monitoring is. I mean, if you don't have visibility into that, how much of your link is being utilized, or see how the traffic pattern is, and that too in real time, it's like having a car which doesn't tell you the speed or the miles per gallon. I mean, you really need to know the information. You really need to see at what speed are you driving or what speed are you traveling, because only then you can slow down if you're going above the limit. Or all this finally helps you get the best performance from your car. So the same with your network. You need to know the traffic speed or traffic volume or utilization. See how the traffic pattern is, when is the link the most utilized or underutilized, and then based on that, schedule the big backup jobs. All this can help get the best out of your network. So then comes the traffic analytics. So that is finding out the who, what, when, and where of network traffic. So who tells you the source, which IP address in your LAN is using the bandwidth, or which IP address from the internet is the source of that conversation, which simply seems to be noise and maybe not any business applications. So this helps you to determine if the traffic you're receiving is genuine or not. And then you can take decisions to block the source of the conversation if it is possibly a DOS attack, or maybe bring down a server in your data center if that is the source of all the spam mails that went out of your network. The next important part in traffic analytics is what is using the bandwidth. That is the applications and protocol involved. So information on applications and protocols helps you design your traffic prioritizing policies better. You can tweak your policies as needed, and then really find out if that application is supposed to use so much of bandwidth, and maybe that another application, the application is supposed to get so much of priority or not. So that is what the what part of your traffic analytics answers. And then there is a when and where. So when answers questions like when did a traffic spike happen, or when a particular traffic conversation happened. So here most of you will definitely prefer real-time reports. So with the real-time reports, you can see almost network issues almost as soon as they happen. And something else that is preferred is the ability to store them for later reporting and trend analysis. Now, you just don't want real-time reports, you also want options to save the data. The reason is, I mean, say like over a weekend, someone comes and tells you all of a sudden, all right, what happened to the network? Was the network down? Maybe I started a patch on Friday and it didn't complete. Today's Monday and it didn't happen, it didn't go through. You do not know what happened on Saturday and Sunday if you do not have an option to store this data. So when this happens, with the ability to see this information whenever you can or whenever you need it, that is the another important part of traffic analytics. And finally, where, that is the destination IP address. So where is important because if a worm or virus or DOS attack is targeting some IP within your network, knowledge about about that destination IP address helps you isolate the target. So you can actually block traffic to that target, or maybe isolate the target, and if it's a critical server, maybe a business application hosting server, you can actually create some access list and block traffic to it. So you can make sure your business is still running and you're safe from the attack also. And it's not just that, you would also need not just knowing the who, what, or when and where. There's something more to this. The really important factor is capacity planning. Today almost everybody has to take a capacity planning decision, because sometimes the reason being your network traffic has increased exponentially. So this reason, I mean, you would need to know whether, I mean, you're planning for VoIP, like I said earlier. So you would need to know, can your current link meet the demand to carry this additional traffic, or maybe should I increase the bandwidth? So whatever be your answer, a report which can actually substantiate what your opinion is, that would be awesome. So those kind of information, bandwidth monitoring, traffic analytics, capacity planning, all this is an important factor for the for today's network administration. And then layer 7 analysis and traffic management. So today we have almost every network is already 1 gigabit, and now almost everything is moving to 10G networks. So increased bandwidth, which means more number of applications, more users, and maybe even more number of peer-to-peer application usage. So all this is happening around you. And access control list is not the solution for what you were looking for. Because today's high-speed network, it is like your traffic has grown exponentially. How many access lists can you create? There are zero-day malwares. How many access lists can you create, or how can you stop these zero-day malwares about whose signature you do not know about? So today it is important to find out if your bandwidth is being utilized by unwanted application or maybe peer-to-peer applications. Block them if they are present. Prioritize your business critical applications and validate the performance of the policies being implemented to manage traffic. So doing this ensures that your network performance is always at its best and guarded against any sudden use of bandwidth or sudden degraded performance of your network link. And the next part, so this is one of the other factor. The next part is like VoIP has really become the buzzword today. It's like reason is cost savings. You all would know that, but I would say among the customers of ManageEngine I talked to, like almost 90% of the customers have actually implemented VoIP or they're actually planning to implement VoIP within the next 1 year or so. So huge cost savings is the reason behind this. Now, if you're planning to implement VoIP, it's really important to know if your current link has the capability to carry this additional traffic, because VoIP is definitely going to take some extra amount of bandwidth. So can your current link carry this additional traffic? And if it can carry, how would it actually perform? So something like this, look into the future on how this is going to perform if you implement it. That is what another requirement is. Most of the network admins who were planning to implement VoIP say, all right, how I wish I could see how my VoIP traffic is going to perform, and then I run it on these links. So maybe for those who have actually even implemented VoIP, there should be some method to measure the performance of recurrent VoIP calls or voice calls. So that is something else that network administrator would need to do. And then equally important to this is, or maybe I don't know, maybe much more important is the measurement of the link quality. So what happens is quality measurement in the link is the in terms of data traffic, like finding out how much is the jitter or how much is the latency, packet loss, round trip time. All this you need to measure and verify if your ISP is actually delivering as per the SLA. So I read somewhere that a huge number of ISPs SLA violations actually goes unnoticed because most of the enterprises today, they do not have mechanisms in place to measure the SLA. So something to measure the SLA, something to find out what is the latency or jitter, and something to get back to your ISP and tell them, okay, this is not what you promised, or this is not meeting the SLA criteria which we had discussed. And again, the most worrisome aspect today is getting hacked. So I think not many of you would have forgotten that long list of attacks or malwares that happened sometime back on the big enterprises. So that same thing can happen to anyone. You know that very well because all these networks, they definitely have intrusion detection systems or at least a firewall with access list in place. So the numbers have decreased drastically over the last 2 years. So even with these protection systems, they still got hacked. So that is something you do need to be concerned about. Is the current security system you have been using sufficient to stop DOS attacks or maybe malwares? Maybe a virus is already in your network, carried in by one of those users who use this laptop in an unsecured public network, public Wi-Fi network. So how do you keep an eye on network anomalies and other zero-day malwares that might have bypassed the firewall and intrusion detection system? So that is another point to think about. So the next part is, let's look at the technologies Cisco has to help you with the issues we went through. And all these technologies I'm going to talk about, they are available by default within your device, iOS, absolutely free. You do not have to purchase a license from Cisco to use any of these technologies which we discussed. So we'll talk about some of the solutions, some of the technologies Cisco has to help you with all these performance monitoring requirements. So first requirement we talked about was bandwidth monitoring, traffic analysis, capacity planning, stuff like these. And the solution for all this is the widely used IP traffic accounting technology called NetFlow. Cisco introduced, initially NetFlow was introduced as a switching path, and later when the value of the information, the flows were discovered, NetFlow moved into being a traffic accounting technology. So NetFlow answers questions about the who, what, when, and where of your network traffic. It gives you information on what is the application being used in your network, that application, how much bandwidth is it utilizing, and maybe using NetFlow data, you can even find out how the change, maybe a change you implemented, how that has affected the application performance. You can view the top conversations, top talkers. All together, you can understand the network behavior and see how the network is being utilized. So you can use this information to reduce maybe possible outages. You can do better traffic management, and altogether allowing for efficient operation of the network. Now, improvements in network operations lead to cost savings actually, because network uptime transfers into higher revenues. So we'll just show you very briefly on what is NetFlow, just a few minutes on what is NetFlow for those who are not aware of it. So when IP traffic passes through your device interfaces, certain information from the traffic packet header is captured and it's stored into a cache on the device. And then this information is exported in a timely manner based on the configuration you put on your Cisco router or Cisco switches. Even the Cisco switches actually support NetFlow. So you can actually configure your Cisco device to export packets like every 1 minute or at the lowest is 1 minute, something like that. So you can export these packets, and 1 minute is, I would say, almost like real time. So these packets are then exported in a timely manner based on the configuration, and you can send them to an analyzer software which will capture that records and generate reports. So a NetFlow will contain key and non-key fields. So a set of flows with the same key fields and within a certain time slot is defined as a single conversation. So the key fields in the traditional NetFlow sense are source interface, protocol, source and destination IP address, source and destination port, and TOS field. So I said traditionally these fields are the key fields. The reason is because there is this new NetFlow version called NetFlow v9. So what you saw on the screen now, that is the key field for NetFlow version 5. Whereas the new version of NetFlow, that allows for user-defined key fields, which we'll see that very briefly next. So all new devices from Cisco now come with something called as flexible NetFlow export option. So flexible NetFlow is based on NetFlow's version 9 format, and as the name says, it's flexible to your requirements. So flexible NetFlow, what is flexible NetFlow? That is based on, like I said, already said, it's based on v9 and allows users to customize the key and non-key fields of your NetFlow packet. So you can select what sort of information is captured in the NetFlow packet. It also allows users to capture new elements of network traffic that could not have been included with your previous version of NetFlow called as the NetFlow v5. So maybe earlier you saw that screen, or let me just go back to that screen. So you earlier saw this, what you can see on the screen is the traditional key fields captured with NetFlow v5. So this was used to identify that a set of flows belong to a single conversation. Now this has changed. Maybe you can change this with your flexible NetFlow. What you can do is you can maybe select, maybe you need only protocol, source IP, and destination IP as the key field. You can do that with flexible NetFlow. And then new stuff like technology has developed. So new stuff is coming. So MPLS labels, IPv6 conversations, VLAN ID, MAC addresses, stuff like this that could not have been captured with traditional NetFlow, as now can be captured with the flexible version, flexible NetFlow called the NetFlow v9. And what you have is customized traffic monitoring with this. So earlier, if you had to accept NetFlow v5 with whatever data it gave to you, you don't have to do that anymore. Say yours is a high traffic environment. You just need information on source and destination IP address with applications used, like I just said. So maybe you're not interested in DSCP or TOS field. That can be done with NetFlow, but I'm not really sure how many of you would actually do away with DSCP values. So anyway, that is what flexible NetFlow is all about, customized traffic monitoring. Now, these are some of the platforms from Cisco that includes NetFlow support, or rather flexible NetFlow support actually. Like Cisco ISR 7200, Cisco ASR, Cisco CAT 4000 series, 6000 series, and even Cisco's ASA, the firewall device from Cisco, as well as the 3500, 3570 Catalyst switches. All these now support NetFlow export. So even if you don't have these devices or these IOs, even then you would actually get NetFlow v5 support. So almost every Cisco device, starting with Cisco 800 series, supports NetFlow export either as NetFlow v5 or v9, and so everybody can actually start leveraging on these technologies. One of the first questions I get when I talk about NetFlow export from a router or a switch is the performance impact. So as you can see here, 10,000 flows per second. So, or 100,000 flows or 10,000 flows per second from a single router is huge. That kind of traffic, I've actually seen it only mostly from ISP devices or from really, really huge enterprise with lots and lots of traffic. So these 10,000 flows per second on a single device just cost maybe somewhere around 7% of additional CPU. Now remember, 10,000 flows per second from the whole network is what almost, I would say almost 99% of the users have. And what we are talking about is 10,000 flows per second from a single device costing just 7% additional CPU. So that clearly shows you the performance impact by enabling NetFlow export is minimal. Now another question is bandwidth. If I export NetFlow, will NetFlow use up my bandwidth? Will I end up like my business critical applications not working? Something like that. Now NetFlow export from a router creates an extra load of around 2% on the interface through which NetFlow traffic is exported from each router. So let's say you have a router with 3 interfaces, you enable NetFlow on all the 3 and export it through a serial, maybe a LAN interface. So that is just going to be additional 2% load from that router. So maybe I'll rephrase it and say that all these years I've never come across an issue or a case where bandwidth has dried up because NetFlow data was being exported. So that is very safe for you, flexible NetFlow. You don't have any impact on your network devices. You don't have any impact on your network itself. Using flexible NetFlow, you can see what is happening on the network, who is using a bandwidth, what sort of performance is your network giving, what sort of performance is your application giving. And then something else we discussed is layer 7 traffic analytics, like you see on the screen. Definitely everyone likes to see physical data link or the OSI layer as it is, what sort of application is being used. Every network guy out there would definitely like to see that. Now, NetFlow can tell you what is the application used, but then there are those certain applications which actually hides behind well-known port numbers or uses random port numbers. Like say BitTorrent. BitTorrent is an example. BitTorrent is very commonly used nowadays. I would say even I use BitTorrent at home. So a large number of users use BitTorrent, and BitTorrent can be set to use port 80. That's HTTP port, and as far as I know, most of the networks do not block port 80 traffic as it is web traffic. So how would you find peer-to-peer application usage? Find applications that use your well-known port numbers, hide behind the well-known port numbers, and take up your bandwidth. So that is where Cisco NBAR comes in, network-based application recognition. So NBAR classifies an application not simply based on port and protocol mapping, but it does a deep packet inspection of the interface traffic, including the payload. So using NBAR, you can actually identify BitTorrent traffic, Kazaa, Skype, eDonkey. So any application that could have hidden behind well-known port numbers, that can be identified. Now, another big advantage of Skype, another big advantage of NBAR is it can identify your custom applications. What it does is it can do a payload inspection and identify whatever applications are used or custom applications that are used in your network. It can do a custom identification based on maybe keywords present in the traffic header or maybe even the traffic payload, and it can identify or classify a protocol. So what it is doing is you are taking traffic management to a higher plane, because using this NBAR's custom identification and then combining it with Cisco's class-based quality of service, you can actually do a lot of traffic management. So you should actually check out some of those ManageEngine blogs we have for information on uses of NBAR. So what you can do is, using NBAR, you can identify your custom application or do a payload inspection and based on a keyword, track down an application and once you do that, then you can associate this application to a QoS policy to prioritize that traffic or block those conversations. That is traffic management. This is what brings us to class-based quality of service. So on the screen, what you can see is this is what typically will happen in all your networks. Your applications fighting with one another for the bandwidth. So you will have all sort of applications, web traffic, VoIP, SLTP, a long list of wanted and unwanted applications, and all of them are fighting for your bandwidth space. Now you have a lot of bandwidth, but there are more number of applications. If you have less bandwidth, all these applications are going to fight for the bandwidth. So you will definitely want to stop some of the unwanted applications, prioritize the ones that are critical to your enterprise, and after you use NetFlow and identify the unwanted stuff, or after you use NBAR to find the peer-to-peer application usage, management of traffic is what is needed, so that, as you can see here, all those 4 applications are coming into your internet link trying to go out through the WAN. So using your traffic policies, you can block them, making sure only what is needed for your network goes out. This is what CBQoS is going to do for you. You create traffic classes and associate them to policies which can manage the traffic. So this way you can actually block unwanted applications, prioritize your business application, like that ensure the delivery of your business critical apps. So you can prioritize it, block it, limit it, allot a certain percentage of your bandwidth, not just blocking it or giving it more important. You could actually say, all right, 50% of my bandwidth goes to HTTP, 30% goes to VoIP, and the rest 20% goes to, all right, something else. You could actually prioritize it like that. So that is how good CBQoS is for you. Traffic management, and all this is there by default on your Cisco router. You only have to start using it. You only have to start leveraging on it, and you can actually see the results very fast. And another requirement or wish list is, or what we saw was the need to measure the IP performance. Be it VoIP or data traffic, Cisco IP SLA is a powerful technology designed for this purpose. So Cisco IP SLA actually helps monitor the performance of a link. What it does is it sends a simulated data or voice packet across the link and reports the performance metric. You can actually view the jitter, latency, packet loss, round trip time, and you can actually see if the packet reaches the destination or not, how much percentage of packets are lost. That is the link, I would say they call it as the link availability. So how much percentage of the packet is lost. You can measure the performance of your link when carrying traffic. So on a day when you need to deploy VoIP, you'll definitely want to know if the link can carry it. After all, you're not going to experiment with how the VoIP is going to perform by deploying it in a live scenario. You would like to measure what would happen first. So that is where IP SLA can help you with. So once you find the jitter and latency or some of the other stuff you're really interested in, and if you have not got what has been promised to you by the ISP, you're armed with reports now. Using Cisco's IP SLA, you get your reports, and now you can show your ISP, all right, this is not what was promised, or maybe you can show your boss, all right, fine, we'll need another link for the VoIP traffic, because look at these reports, there's going to be a high amount of jitter, or maybe there's a huge latency, which is actually going to make your calls sound real bad. So IP SLA is not just for ISP performance, verifying your ISP performance, or your VoIP quality performance. You can reliably and predictably measure network performance, or measure how the QoS policy change has affected or maybe improved the traffic behavior of applications over WAN. You create a QoS policy, you implement a CBQoS policy, which we saw earlier. Now you would like to know, all right, fine, is there any change as the latency decreased, as the VoIP quality increased? How do you measure it? Again, you're going to use IP SLA. So that is how so many things that IP SLA can do for you. And finally, to the most critical aspect, which is again security analytics. Many of you, I think many of you are already using NetFlow, but I believe there are only a very few of you who use NetFlow for network traffic anomaly detection. Now, anomaly detection is something most of you people might not have done with NetFlow or NetFlow traffic. You might have been using NetFlow for bandwidth monitoring or traffic analytics, but anomaly detection is something new. NetFlow packets, in addition to these traffic analytics, what it does is it carries these very detailed information about your IP traffic, and using that, anomaly detection can be done. So what happens is even minor changes in traffic pattern is captured in NetFlow, and stuff that might have been ignored by these modern day intrusion detection system, IDS or IPS, and firewall rules are immediately captured by the NetFlow data. So NetFlow helps mitigate attacks by identifying them in real time and giving you information about the offender. You can see information about what was the target, the route through which the attack was supposed to take place, all this. So NetFlow's security analytics, NetFlow for security analytics is something people should really start exploring or start using, because all that information is lying down there in your Cisco device. So out of the many map technologies we saw now, I think you might already be using a number of them, but how many of you are leveraging on all the free options available? So that is the big question. Let me see if I can get a poll to find out like how many of the technologies which we discussed are being actually utilized. Give me 1 minute. Let me just try to get that poll up. So the poll is now open, and you can see on your screens like what are the options you can you have. So you can put in your vote, and we'll announce the results shortly. So the poll should be open on your screen now. You can select the options. So which of the following technologies are you currently using? That is, the options we have on your screen. It's NetFlow or SFlow or IP6. That's for traffic analytics. I've been talking about NetFlow all the while because Cisco started off with NetFlow and the rest of the vendors followed suit. And NetFlow is most famous or the most commonly used out of the monitoring technology. And then there is Cisco's NBAR, that is the day packet analysis mechanism. And then there is Cisco CBQS for prioritizing your traffic policies, or I'll say traffic management with Cisco CBQS. And then Cisco's IPSLA for measuring the performance of your traffic, how your link is performing, how your packets are performing, measuring the performance. And then there is Cisco NetFlow for security analytics. I think not all the users who actually use NetFlow would actually be using Cisco's NetFlow for security analytics. I mean, NetFlow for traffic analytics wouldn't be using it there for security analytics is what I think. But let's see. So we are about to close the poll now. All right. So if you have yet to vote, you can take a minute. I'll just wait for a couple of maybe 5 to 10 seconds, because it's a very simple code. You just have to select what you have on screen. All right. So let's see what the results are. All right. That's great actually, because almost every one of you, like I said, every one of you have been leveraging on NetFlow or SFlow or IP6 for traffic analytics. But look at the numbers there for CBQS. CBQS is an excellent, awesome technology that you should actually be using. The reason is traffic management. I have received a lot of questions regarding how I can manage my bandwidth. NetFlow gives you NetFlow Analyzer, or NetFlow gives you information about what is using the bandwidth, who, what, when, and where of traffic. But how do you manage it? That is what CBQS is going to do for you. So CBQS can help you block your traffic, prioritize your traffic, set your bandwidth, and that is why you should be using CBQs. And NBAR is a good result. 15% of the people, they're using NBAR. So NBAR, again, it's not simply layer 7 application identification. NBAR is much more than that. You can track your own policies. You should actually, maybe if you have time, you should actually talk to one of our the ManageEngine technical team members, and they can actually guide you how you can use Cisco NBAR for your custom identification, and then associate them with your CBQs policies. And then again, Cisco IPSLA, and that's also, I think we should see over the next few years, we should actually see Cisco's CBQs being used as good as how much of NetFlow or SFlow is being leveraged on. And then IPSLA usage also should be increased, because that is the only method by which you can actually verify if your ISP is giving you what is promised. So let's now get back to the presentation. So we'll now talk about NetFlow Analyzer, ManageEngine, NetFlow Analyzer, and Cisco. So what does ManageEngine NetFlow Analyzer do? How does it leverage on the information available from these Cisco technologies? That is what we'll be able to see. So using NetFlow Analyzer definitely uses NetFlow. So what you get is a comprehensive understanding of your network using Cisco's NetFlow. It's not just NetFlow, like I said. We can use SFlow, IPFix, NetStream, name it. Whatever flow formats there are out there in the market, you can actually utilize that. So what we do is ManageEngine, we use NetFlow data for bandwidth and traffic analysis. We help you visualize your traffic pattern with real-time graphs. So the lowest time period at which NetFlow data can be exported is 1 minute. So we give you real-time graphs, and then traffic analytics with application and conversation report, or you even get trend analysis and application analysis for capacity planning. So these are some of the reports. What you can see on the screen is the report that is available from NetFlow Analyzer. That's a traffic report. These are just some of the very few screenshots I've taken. There are free demos which you can actually take a look at. So you can see the traffic based on volume or speed or utilization or packets. You can see your real-time report, and you can even see just above the graph, it says 1 minute averages. So every 1 minute you're getting an update on what is happening. And look at the conversations. You get to see the source IP, destination IP, application, port, protocol, DSCP, traffic. Maybe I shouldn't talk much about NetFlow, reason being almost everybody or one of you have already been using NetFlow. So this is how the capacity planning looks like in NetFlow Analyzer. So let's get on to NBAR. Let's get on to some of those technologies not many of you are using now. So NBAR, or network-based application recognition. So that's like we already saw, deep packet layer 7 traffic analytics. So NBAR reporting, it can be done by either SNMP or by flexible NetFlow. And Cisco, NetFlow Analyzer, ManageEngine NetFlow Analyzer supports NBAR data collection by both SNMP as well as flexible NetFlow. So if you're not interested in SNMP data collection, you could use flexible NetFlow. And those who just want the traditional method of NBAR collection, we support that also. So with NBAR, you can identify the host involved in peer-to-peer traffic, manage your bandwidth like we saw with the CBQs. And these are some of the reports. This is the report that NBAR can give you. All these list of applications are something which normal NetFlow-based recognition might not work if they use a well-known port number, if they hide behind a well-known port number. So flexible NetFlow collection, NBAR data with flexible NetFlow collection. And the important factor, class-based quality of service reporting. So using CBQs, you have managed your bandwidth. You have blocked something, you have dropped some traffic, you have put 50% priority for your VoIP application. Now, how do you actually know whether it's working? That's really important. You know, I think a lot of people out there who would be implementing or who are planning to maybe look at CBQs after you came to know about it here, it's really important to know, did it really happen? Did it really work? Maybe did I block some of my business applications? So that is where NetFlow Analyzer comes into the picture. NetFlow Analyzer can use CBQs reporting, can do CBQs reporting. It can help you validate your QoS policies. It can monitor and report on the pre and post policy traffic usage. That is, how much of traffic was there before the policy's effect, how much of traffic was there after the policy effect, what is the drop in traffic, what is the queuing, and you can even see a report for each of the match statements. In CBQs, you create match statements and you match certain traffic conversations or traffic applications to a policy. So you can see the report for each match statement. So something like this, you can see on the screen here, pre-policy usage, post-policy, what is the drop in traffic, that can also be seen. Something like this. So before the policy, there was so much volume of traffic, and maybe like 15% of your mission-critical applications have been dropped, or something else like transmission data, which is not really very important. Transmission data actually covers your backups. So transmission data, 20% or 22% of your transmission data has been dropped. So detailed information like this. Then comes Cisco's IPSLA for VoIP monitoring. So VoIP performance analysis using Cisco IPSLA can be done by NetFlow Analyzer. You get to see reports on jitter, latency, packet loss, and MOS. MOS is the mean opinion score, which actually rates the quality of the VoIP call. So you actually compare VoIP reports with the interface level NetFlow report. So when the quality of VoIP call goes down, you can look at the NetFlow report and find out what all applications were being used. Or you can look at the QoS report for the same time period and find out if maybe applications or VoIP traffic was being dropped by QoS. So you can identify the reason for VoIP quality degradation, or you can actually measure if your link is capable of carrying VoIP traffic. So look at the report there. You see graphical, very easy, simple reports there on screen. Source to destination jitter or destination to source jitter. What is the MOS score? How your calls are performing? What is the packet loss? And you also see reports for the call. Maybe the top calls by jitter, or what is the highest latency you had in your network. And then there is the WAN RTT reports, WAN round trip time. So link performance analysis using Cisco IPSLA is what is being done here. So earlier you measured the VoIP quality performance. Now you need to know how your data traffic is going. So for data packet reports on jitter and latency, packet loss, round trip time, link availability, whether the packet is reaching the destination. All this is done with NetFlow Analyzer. All this can be done by NetFlow Analyzer. And the best part about IPSLA monitoring with Cisco's IPSLA monitoring with NetFlow or NetFlow Analyzer is you don't have to get to know about the commands which you have to run to apply or create an IPSLA. What we have for you is a GUI, a graphical user interface through which you can create your IPSLAs, and NetFlow Analyzer will use them and give you the reports. So in short, you just type it in as normally as you do stuff. You don't have to go searching for the CLI commands of your Cisco router. So view the least performing path, find out which of your link is doing the worst when carrying traffic, and then talk to your ISP. So look at these reports which NetFlow Analyzer can give you with using or leveraging on IPSLA based on WAN RTT. So you get to see least performing path, or the least available path, and health reports for your link. And then again, the round trip time for a link, like what is the minimum round trip time, average round trip time, and the max round trip time. Really important to see how your VoIP calls are doing. Availability, a graphical report for everything, which makes it really simple to view and analyze and understand the reports. And finally, we come to flow-based security analytics. Now, network anomaly detection leveraging on NetFlow data is something a lot of NetFlow vendors out there in the market do not do. There are only very big vendors or the real costly ones who are doing this flow-based security analytics. And then ManageEngine is doing this for you, at something which everybody can afford. So you can detect anomalies that comes beyond your firewalls and IDS. And anomaly detection in ManageEngine NetFlow, it classifies based on the offender, target, the path, or the type of problem, the type of attack you're under. And it's real-time threat detection. We have something called as the continuous stream mining engine, which actually a registered patented technology from ManageEngine. Using that, what we do is we do a real-time traffic analysis and give you real-time updates on the network anomalies or network incidents that are happening, anomaly incidents that are happening. So look at those reports there. Now, you can see all those different classes we have, and under each classes, what are the different problems that are identified, stuff like these. And another good part is you can actually customize it. You can actually fine-tune the reports to reduce false positives, so you don't actually get too many of false alerts. So we actually now saw a number of technologies here, but how many of you think you can actually use all of these technologies in a single software? I'll just take one more poll just to find out which among the following technologies would you actually prefer. We discussed around 4 to 5 technologies. I mean, NetFlow itself in 2 parts. And so let's see, NetFlow itself was discussed as traffic, analysis part, as well as the security analytics part, as well as the monitoring part. So which among the below technologies, like you see on the screen there, will you choose for your network performance monitoring? Is it will you choose one out of it, or maybe all 4 of the options? So yeah, we're just going to close the poll in another maybe I'll say 10 seconds. You can just select the options, whichever you prefer, whichever you most prefer, or maybe if you wish to see all those 4 options in your network, you can go ahead and select that too. So yeah, I'm closing the poll now, and we'll have the results on screen. Right. So everyone prefers, what you can see is everybody prefers detailed traffic analytics, and a large number of administrators actually prefer basic bandwidth monitoring reports. So now, wouldn't it be good if you can actually get all these reports which we saw, basic bandwidth report, detailed traffic analytics, capacity planning, real-time traffic usage update, security analytics, performance monitoring, every one of those technologies what you saw, instead of going through different tools, instead of buying multiple tools, instead of buying costly software, if you can get all this into a single tool, that is what ManageEngine, NetFlow, and Lysa will do for you. So throwing in more bandwidth does not improve the performance, does not always work out. You actually need to do a complete performance monitoring of your network. You can measure it using the free technologies available on your Cisco device. You don't have to purchase anything at all from Cisco. All these, utilize those technologies that are available, find the bandwidth being used by your business critical apps, and then use NBAR and find out if there is any unwanted application, and then you use your CBQ's policies, block the unwanted application, prioritize your business apps, or maybe manage your bandwidth better, and then use IPSLA and measure how things worked out after you created your QoS policies, or maybe even before you create your QoS policies, run IPSLA, find out the performance, talk to your ISP, then create your QoS policies. Once again, measure the performance using Cisco's IPSLA and see how the link is performing, and do a security analysis beyond, get all those anomalies that comes beyond your firewall and IDS. Keep your network protected with the 3rd layer of security using NetFlow. So all this using a tool that can leverage on all these technologies which we talked about. Use a tool like that. So ManageEngine NetFlow Analyzer is one such tool which can utilize all these tools, all these technologies. So you should find a tool which you can utilize. A tool which can leverage on all these options. Like that, you save money. But more important than using the tool is you starting to use the technology that is available on your Cisco router. So that brings us to the end of the webinar. We'll start taking questions now. I think my expert panel here, Alec, has already been responding to some of the questions that were being raised directly to the panel admin. So any questions, you can start typing in your question using the chat window. So users, everyone can type in your questions. So one of the questions being raised is do we have options to schedule all the reports which whatever I showed on the screen, whether the reports can be exported to PDF and Excel. Every report which you saw on the screen, they can actually be scheduled to be sent to you by email. And it's not Excel option which ManageEngine has. What we have is CSV and PDF export option of all your reports. And another question what we have is for traffic management. We've been asked whether traffic management or QoS policies, can that be done directly from ManageEngine? The answer is no, but our team here, they can assist you with how to create your CBQoS policies. We've got a lot of blogs written about how to create your CBQoS policies, what CBQoS can do for you, stuff like these. So you can refer to those blogs, or you can just give a call to one of our technical engineer, or maybe just visit netflowanalyzer.com, raise your question, and our technical engineers will answer them. So you cannot manage you cannot create QoS policies from NetFlow Analyzer, but NetFlow Analyzer can use that information and tell you how the QoS policies you created were performing. And another question that has come in is video traffic monitoring. I think the user is referring to MediaTrace, the new technology from Cisco. Yeah, the current release of ManageEngine NetFlow Analyzer is 9100. So in that we actually do not have MediaTrace, but the next release in 2 weeks has MediaTrace. And for those of you who are not aware of what MediaTrace is something like Cisco's IPSLA, except that it helps you measure the performance of your video traffic. So like today everybody is shifting to unified communications, so lots of people would actually want to know, all right, unified communications means voice, not simply voice calls, it also involves teleconferencing, video calls, stuff like this. So you would like to know how was the clarity there. That is what MediaTrace is going to provide. And yeah, MediaTrace and MediaNet, these two technologies is being brought in by ManageEngine NetFlow Analyzer in its next release due in 2 weeks. And any other questions? Some of the questions my expert panel is actually replying to. I'm taking up some of the questions that can easily be answered over the phone. But definitely every question will be answered. Like maybe we'll have it for another 5 minutes. So any more questions? All right, so thank you everyone for joining the ManageEngine webinar. We'll keep you posted about the next one, and those questions which were not answered, we'll update them by email. So once again, any questions on NetFlow Analyzer, email us at nfs@manageengine.com. Sales questions, you can email sales@manageengine.com, and you have the website address there on screen. So thank you everyone once again for joining. Have a great day.